In the last video, we talked about the definition of equivalence, and we introduced one way to decide whether two propositions are equivalent, which is using truth table. So in order to know whether the two propositions are equivalent, you can draw the truth tables of both propositions, then compare them row by row. If they always have the same truth value for every single combination, then we say these two are logically equivalent. However, obviously this method does not scale. If you have a large number of propositions, then the truth table will be huge. Therefore, in this video, we'll introduce 9 groups of equivalence laws that you can use directly to prove propositions to be equivalent. The first one is double negation law. The negation of A is equivalent to A. The second group is identity laws. A and true is equivalent to A. The reason is when A is true, true and true is true. So the same truth value with A. When A is false, false and true is false, which is also the same as A. Therefore, they are equivalent. Similarly, you can check the second one. A or false is equivalent to A. The third group is called domination laws. A or true is equivalent to true. According to the truth table of OR, as long as one of the two disjuncts is true, the truth value of this OR connective is always true. And similarly, A and false is equivalent to false. Again, according to the truth table of AND, as long as one of the two conjuncts is false, the whole proposition is always false. Next, commutative laws. What it says is you can switch the order of the two disjuncts or conjuncts, then the resulting proposition will be equivalent to the original proposition. Next one, associative laws. There are 2 of them. What it says is if in the proposition all the connectives are the same kind, for example, the first one, both connectives are AND, the order for you to calculate the truth value does not matter. They will always have the same truth value. Similarly, if both connectives are ORs, then the order does not matter. Either you calculate A or B, or you calculate B or C, you have the same truth value. Next one is called idempotent laws. It says A and A is equivalent to A. A or A is also equivalent to A. Next one, distributive laws. This one is very similar to the distributive laws in algebra. So it says A or B and C inside the parentheses is equivalent to A or B together and A or C together. Similarly, A and B or C inside the parentheses is equivalent to A and B inside the parentheses or A and C inside the parentheses. Next one, De Morgan's laws. The first one says the negation of A and B is equivalent to not A or not B. And the second one says the negation of A or B is equivalent to not A and not B. Now, if you recall, in the very first lecture, when we talk about given a proposition, how could we find its negation form? So this law basically explains why when you have an AND in the original proposition, when you find its negation form, AND becomes OR. And similarly, if in the original proposition, it's an OR, and when you find its negation form, it becomes AND. Last group is implication laws. And in the previous lecture, we already showed that these three propositions are equivalent. And we are going to use this implication law a lot in the rest of this class. So now we have seen 9 groups of equivalence laws. I want to emphasize that equivalence relation is bidirectional. Using discrete law as an example, this side is equivalent to this side. Of course, this side is equivalent to this side. Okay, why do I emphasize that? Because when you apply the equivalence laws, be flexible. You can use both directions depending on the question. If you want to apply the reverse direction of the distributive laws, you have to make sure your proposition is in this form. Basically, you have two propositions connected by AND. And within each proposition, you have the same connective, which are different from the connective connecting these two propositions. And last condition is these two propositions inside the parentheses, they should have a common letter. Then you can apply this reverse direction of the distributive laws. Next, we are going to see how we can use those laws to answer some questions. The first one is a straightforward proof of two propositions to be equivalent. Here, you don't have to start from one particular side to the other. You can start either side you want, depending on how easy it is. For example, if I change the order of these two, I swap the position of the two sides. And when you see a problem like this, you can start from the right side to the left side. Okay, why do we start from the longer proposition to the shorter one? Because if the proposition is longer, there are more opportunities for you to apply one of the 9 equivalence laws. Now let's see how we can use the 9 equivalence laws to prove these two to be equivalent. So if you look at the left side, since the connectives outside the parentheses and inside the parentheses are different, you cannot use the associative laws. However, you can use the distributive laws. That's what we are going to use. So by applying distributive law, you can transform the left side of this one to this one. Then next, what do we do? It seems like we cannot apply any one of the 9 equivalence laws to further transform this. However, we can still apply what we learned from other videos. For example, this one, what is it? A or not A? It is always true because that's a tautology. Therefore, you can transform this into this. They are still equivalent. Then, based on the identity law, true and some proposition is equivalent to that proposition. So now you can see we have this side. And since we use this equivalence relation chain to connect the left side to the right side, then we can conclude this one is equivalent to this one. So we are done with the first example. Second one is another way you can apply equivalence laws, which is how you can simplify a proposition. And now, what should we do? Well, some of you may say, well, since the connective outside the parentheses is and the connective inside the parentheses is and as well, so we can use the associative law. That's not true, because for the associative law, let me write it down. Right? But in the proposition we are trying to simplify, there's a negation outside the parentheses. Therefore, you cannot use associative law directly. So what can we do? Since there's a negation outside the parentheses, we can apply the De Morgan's laws first. Therefore, we copy A and here, then apply De Morgan's law here. Then we have inside the parentheses, not A or not B. Here, do not forget the parentheses. If you change that, you change the proposition. Next, what do? Well, here the connective outside the parenthesis is different from the connective inside the parenthesis. Then you can apply the distributive law. So you have A and not A inside the parenthesis, or A and not B inside the parenthesis. So that's distributive law. Then we know this one in the first parenthesis is always false, or in other words, it's a contradiction. Therefore, this one is equivalent to false. Then we copy this down. Then false or some proposition is always equivalent to that proposition, where we applied identity law. Now, obviously, you cannot further simplify this one. So we'll stop here. So we show that the original proposition is equivalent to this proposition. In addition, we see that there are 3 letters in the original proposition, and now we only have 2 letters. So we simplify the proposition. Some of you may ask, how do we know which laws to use to simplify a proposition? Let's review these 9 laws again. Remember, our goal is to reduce the number of letters in the proposition. So if you look at those laws again, you can see for the identity law, you can go from 2 letters to 1. And for domination laws, you can go from 2 letters to 1. So those are the 2 laws you should consider. In addition, if you look at this distributive law, you can see for the reverse direction of these 2 laws, you go from 4 letters to 3 letters, right? You go from 4 letters to 3 letters. So those are the laws you should think about when you try to simplify a proposition. Last example. Show this implication is a tautology. Before this video, the only way we can show this a tautology is to show this implication is always true, regardless of the combinations of the truth values, correct? But now, how can we use equivalence laws to show this is a tautology? If you remember in the previous video, when I talked about the relation between equivalence and the tautology, I said to show a proposition is a tautology, you can just show this proposition is equivalent to true. That's what we are going to do for this question. We are going to show this proposition is equivalent to true eventually. But obviously, we have to do this step by step. But where shall we start? If you look at the hypothesis, it's just A and B. There's nothing you can do there. If you see the conclusion, it's just A or B. There's nothing to do there either. However, this whole proposition is an implication. And if you recall, the last equivalence law is implication law, which says the implication is equivalent to not hypothesis or conclusion. Now, you have 2 options. One, you can think of this one as a single letter, let's say C. Then it becomes C or A or B, where you can apply the associative laws. That's fine. That's totally fine. However, what I would prefer is I will apply the De Morgan's law on this one. Then you have this proposition. Now you can see all the connectives in these propositions are ORs. Then you can apply associative laws to remove the parentheses, because if you have the same connective, the order does not matter. Then you can apply commutative laws to move those propositions around. Okay, so you can see basically I swapped the position of not B and A. Why do I do that? Because there's a not A here, and if you can combine this not A and A, you can simplify this proposition. Similarly, since there's a B here, if you can move not B closer to B and somehow combine them together, I'll be able to simplify it. Now we can apply the associative law again to combine the letters we want to combine to form this proposition. And then you can see this one is a tautology, this one is a tautology as well. So you have true or true, which is of course true by idempotent law. Now you can see we go all the way from the original proposition, and we show that it's equivalent to this one, then it's equivalent to this one, and so forth until we show that it's equivalent to true. So if you look at these two ends of this chain, we can conclude that the original proposition is equivalent to true. So now we have seen 3 examples on how we can apply equivalence laws to solve some problems. For example, in the first one, it's just a straightforward proof of equivalence relation. Second one is to simplify a proposition. And third one is to prove a proposition is a tautology. For these 3 examples, I always show you the name of the law we applied. However, this is not required. You don't have to memorize all the names of the laws. So when you work on the homework or exam, you don't have to show me the name of the law you applied. At the end of this video, I would like to show you 2 exercises that you can work on after watching this video.